Today we're going to be talking about the definite integral. We're going to be talking about what it means, how to evaluate them, and what they mean in context, okay? So first, let me draw out a definite integral for you. The integral symbol from a to b of some function f of x dx, okay? So in order to evaluate our definite integral, we first need to find the antiderivative big F of x, such that if we take the derivative of big F, we get f of x. Okay, this is our antiderivative. F of x is our antiderivative. Okay, sometimes you can just look at something and reuse your reasoning to figure out, what might be a suitable antiderivative for this function? Okay, and if I were to say find the antiderivative of f of x equals x squared, you'd say, well, I know the power rule, so let me try and do that in reverse, okay? I know when I do the power rule, I need to take away one number from my exponent. So if I want to do that in reverse, I need to add one number to my exponent, okay? So if I have x to the third and I want to take its derivative and get x squared, I'm going to knock this number down by 1. I'm going to reduce my exponent by 1. And I'm also going to multiply the whole thing by 3. So, since I don't have a coefficient here, I need to divide this whole thing by 3. And this is going to be my antiderivative, my big F of x. So if I do the power rule on this, I take the 3, pull it down, my 3's cancel out, and I'm left with x squared. Okay, so cool, I found my antiderivative. Now let's go through the more formal rules for finding the antiderivative. The anti-power rule, as you have just seen demonstrated, is x to the n plus 1 all over n plus 1, where n is your exponent. So if my exponent is 2, it becomes 2 plus 1, 3, all over 2 plus 1, which is 3. That's my anti-power rule. Just like when we were taking derivatives, if I have the integral of x squared plus x dx, if I want to find that antiderivative, that's the same as finding the antiderivative of x squared plus the antiderivative of x, okay? So you can separate the variables with plus and minus signs between them and take their integrals or take their antiderivatives separately. Next, we have constant multiple, where if I wanted to find the antiderivative of 4x squared, that's the same as finding 4 times the antiderivative of x squared. Then you have your antiderivatives of the more unique types of functions. So the integral of cosine x, or rather the antiderivative of cosine x, is sine x. And with the trigonometric derivatives, you just go backwards one step. So if the derivative of cosine x is negative sine x, then the antiderivative of sine x is negative cosine x. We also have the antiderivative of e to the x. Remember that the derivative of e to the x was e to the x, so the antiderivative of e to the x is e to the x. One that we should know about is if I'm trying to find the antiderivative of 1 over x, that is equal to the natural log of the absolute value of x, okay? Now, there are other more advanced integration techniques, more advanced antiderivative finding techniques. Those include u substitution, those include integration by parts, those include partial fraction decomposition, and those are topics that we have assigned their own separate video for because you need a good amount of time to understand them. Integration by parts is the inverse of product rule. U substitution is the inverse of chain rule, and there is no inverse of the quotient rule because the quotient rule can just be replaced by a product rule and a chain rule, okay? If you don't know what that means, don't worry about it. Just know that the only two you need to know are the anti-product rule and the anti-chain rule and partial fraction decomposition. So if you are taking exams on those more advanced integration topics, go watch those videos. They are very important to know. Anyway, back to definite integrals. So as I was saying, when we are evaluating a definite integral, our first step is to find the antiderivative for our function f of x, okay? Let's do an example of that real quick. Let's say I have the integral from a to b of x dx, okay? And let's say a is 1 and b is 4. So I see x here, I want to find its antiderivative. How about I just do some anti-power rule? So that's going to be the antiderivative, big F of x, is equal to x squared over 2. Okay? Now that I found my antiderivative, I'm going to say that the integral from 1 to 4 of x dx is equal to, in big square brackets, x squared over 2 evaluated from 1 to 4. So that's how this is read. It's x squared over 2 evaluated from 1 to 4. Okay? That's the notation we use. And now, what does this mean? This means that I'm going to take my whatever's inside my square brackets, which is my antiderivative, remember, and I'm going to evaluate it at x equals 4 first. I'm going to evaluate it at the top bound first. So I'm going to get 4 squared over 2. And then I'm going to add a subtraction, and then I'm going to evaluate my antiderivative at my lower bound, which is going to be 1 squared over 2. So what I'm doing here is it's upper bound, it's the antiderivative evaluated at the upper bound, minus the antiderivative evaluated at the lower bound. So I plug 1 in whenever I see x. And now I just need to perform this algebra out. I get 16 over 2 minus 1 over 2. I get 15 over 2. And that is the answer to this integral. That's my final answer, this definite integral. If you're watching this video and you want to know the difference between a definite integral and an indefinite integral, simple answer is the definite integral gives you a number as your answer. An indefinite integral gives you a function as your answer. An indefinite integral is you just stop at the antiderivative and you don't do any more algebra after that. But we're talking about definite integrals now. If you want to learn more about indefinite integrals, go watch the indefinite integral video, linked up there. So let's do another example of a definite integral. I'm going to ask you to work on this. You're going to pause the video, you're going to work on it, then you're going to come back so we can work through it together. The integral from 0 to pi of cosine of x dx, okay? So if we're going to work through this, again, our step 1 is to find our antiderivative, okay? Well, if I take the derivative of sine, I get cosine. So my antiderivative of cosine here is going to be sine x, and I'm going to put that in square brackets, and I'm going to put my bounds here, okay? I'm going to evaluate it from 0 to pi. So that means first I take my sine x and I evaluate it at pi. Sine of pi minus, I'm going to take sine x and I'm going to evaluate it at 0, minus sine of 0. Sine of pi is what? It's 0. Sine of 0 is what? It's 0. 0 minus 0 gives me 0. That is the final answer for this definite integral. And now what we need to do is we need to understand what definite integrals mean in context, okay? So there's 2 contextual applications of definite integrals. And the more common one you're going to see is this, where a definite integral is your area under the curve. So if I were to draw f of x equals x squared, and I were to evaluate the definite integral from 0 to 2 of x squared dx, that the answer that I would get from this, if I were to evaluate this integral, it would tell me the area under the curve between x equals 0 right here and x equals 2 right here, okay? It would give me the area of this shaded region, the area between my function and the x-axis between my 2 bounds, okay? Now, the more useful application that you're probably going to see on word problems, on written responses, is the definite integral is an accumulation of change, okay? What exactly does it mean to say that it's an accumulation of change? Let's say that I have a function f of x, and let's say f of x is the rate at which cars enter a parking lot, okay? So let's say at time, let's say f of x is x squared again. So that means at time equals 0, there are 0 cars entering the parking lot every hour. At time equals 1, there's 1 car entering the parking lot every hour. At time equals 2, there's 4 cars entering the parking lot every hour, okay? So if I were to take the definite integral from 0 to 4 of f of x dx, I am calculating the accumulation of my rate, okay? A rate is a rate of change. If I accumulate my rate of change, if I do a definite integral of my rate of change, then I'm going to understand how much of that item has accumulated. In this context, evaluating this definite integral would tell me how many cars have accumulated in the parking lot. So if f of x is the rate of change of cars, that means the integral of f of x is total cars, okay? How many total cars do I have in my parking lot? Similarly, with, let's say, f of x was velocity of a car. Let's say the velocity, how fast my car is traveling down the highway. If I were to take the integral of velocity from time equals 0 to time equals 30 minutes, it would tell me how much change have I accumulated, or how far have I gone? What is the total distance I have traveled? Because remember, the antiderivative of velocity is position. What is my final position after my traveling, after 30 minutes? Okay? How much distance have I accumulated? So in this case, if I evaluate the integral from 0 to 4, that would be x to the third over 3 evaluated 0 to 4, which equals 4 to the third over 3 minus 0 to the third over 3, which is 0, so I'm going to omit it. And 4 to the third is 64 over 3. Now, you always need to round to the nearest whole car, so this would be 21 cars have entered the parking lot between hour 0 and hour 4. Okay? That is definite integrals, guys. If you found this helpful, and only if you are able, leave a like. If you want more extra help, go join the Discord server or go to meekextrahelp.com. But in any case, have a fantastic day and enjoy life.